Hi! It's never been so easy to illuminate something as nowadays, thanks to popularization of LED technology. You can find them in all shapes, sizes and configurations, also as ready-made compositions like strips, rings or matrices. With so many products on the market, you can complete almost any project you can imagine, from simple improvement of illumination to adding an extraordinary look to common objects or even some totally weird applications. It's really not a rocket science, but still you need to know some basics to achieve what you want. In this video, I'll show you how to handle both standalone LEDs and LED strips using simple and affordable methods. I'll cover monochrome, RGB and addressable versions, as well as some ways of controlling them, from very basic to highly sophisticated, so that you have a complete picture on what is achievable at home and how to do it yourself. So if you have an idea for some sort of illumination but not sure where to start, there is a good chance this video will help. One small caveat for start. Even though such LED strip looks more complex than standalone LED, such prefabricated component is actually easier to handle than single LED. That's because such structures have clearly defined operating voltage and power, so all you need to do to make it working is to provide a power supply that meets those parameters. But if you like to use an LED directly, it's up to you to design your circuit in such a manner that it will limit the current and provide sufficient power dissipation. Still, it's not an overly complicated task, but I'll explain it a bit later. For now, let's just stick to more common matters. Regardless if you use a single LED or some prefabricated composition of those, generally there are three options you can choose. Monochrome, having a fixed color, RGB, where you can set any color you want, and addressable LEDs that allows controlling each LED in a chain individually. Let's start from monochrome option, as it's most basic and probably the most common as well. Here the case is simple. Considering you have sufficient power supply, you just need to connect plus to plus, minus to minus, and boom, you have a light. So if that's all you need, good for you, job done. But in case you would like to have some dimming, transition effects, remote control or other fancy stuff, you need to put some sort of controller in between. In case of RGB version, it's almost certain that you will need one. RGB LEDs are simply three basic color LEDs combined in one package, so this time you have one plus and three minuses, one for each color. Okay, just to be precise, you can also find RGBW models that have additional white LED or even more complex constructions, but the principle is still the same, so let's just stick to RGB for simplicity. The idea is that by altering the brightness of each basic color, you can achieve any color you like at any moment. So theoretically, you still can simply power up only the colors you want, but this way color will be static, so it would be cheaper to just use monochrome version of desired color. Normally, you use RGB to be able to adjust it dynamically, and to do that you need a controller. Finally, controller is a must for addressable LEDs. Such LED have its own built-in power control circuit, so this time you don't need to adjust the power for each basic color yourself. Instead, you send it commands over a specific data transfer protocol, so obviously you need something able to do that. Of course, you can find a lot of LED strip controllers on the market for any given LED version. They usually work on the same principle. Connect the wires as instructed, install the app or use attached remote, and have fun. It's pretty straightforward approach, but unfortunately it has its downsides. For me, the biggest one is that using such ready-made solutions limits your possibilities to whatever was designed by manufacturer. Additionally, such devices are quite expensive in my humble opinion, so the more extraordinary idea you have, the less convenient it will be to build it using stock controllers. So if you are sort of non-technical person that just wants something simple and straightforward, go for it. But if playing with wires doesn't scare you and creativity is your first priority, the easiest, cheapest and most versatile solution will be to use some sort of microcontroller. Okay, if you never heard about things like Arduino, at this point you may think that it must be some sort of joke to combine the words easiest and microcontroller in one sentence. But as I shown in this video, it only sounds scientific. If you ever tried Arduino, you know that the core idea of this project is to abstract all the complexities of programming microcontrollers behind a simple set of functions, so you don't need to dig through hundreds of pages of specific microcontroller datasheet and graduate a university to understand all the concepts inside it. All you need to do is write few simple commands, upload your code to a board you want to use, and that's it. You have an electric signal in real world that behaves exactly as you told it to. So if you are a DIYer, then I strongly recommend that you spare a day to learn at least some basics of Arduino, as I know from personal experience that it opens a lot of fantastic possibilities. For example, in context of LED strips, you can buy such ESP8266 dev board for around $3, connect addressable LED strip, or whatever shape you actually have, upload your code, and boom, you have an equivalent of such controller for more than $20. But the best thing is, this time you have a full control over what your device can do. So if you would like, let's say, several independent strips, maybe even of different types, no problem. You just modify your code and there you go. 2 addressable lights without buying additional controllers and scratching your head on how to make them work together. If it looks to you like some sort of black magic, let me explain what just happened here. In Arduino IDE, you don't need to code everything yourself. Nowadays, there are hundreds of ready-to-use libraries covering all sorts of functions and integrations, so if you are about to use some hardware, there is a good chance you will find a library that already covers what you need. In this case, I used NeoPixel library by Adafruit. You just need to give it the number of LEDs in the strip, pin number on which it is connected, some configuration which usually looks like this, and you're ready to go. The library will deal with all the complexities of sending data, you just need to define which color you like for each pixel. Of course, such static composition is not the most spectacular thing you can do with addressable LEDs. Personally, I like to see some motion. That is also not a problem, you just need to define how your colors should change over time, and display it at some given frame rate or upon some event like pressing a button or any other input you can imagine. For example, you can use Stargate library to replace these static settings with dynamic gate values, configure them as you like, and from now on, you can change them at any moment from web browser in your phone, PC or similar. This is just an example, but if you like to play with it yourself, you can download my code along with some other code snippets used in this video from Do-It-Yourself section of Stargate system page. Here you can also find all the information about Stargate system if you like to give it a try. It's enough to watch these 2 quick tutorials to get started, and if you want to explore some more advanced features of this project, I have the full set of tutorials here on my channel. All links in description. Cool, but as usual, there is a catch. Addressable LED strips typically operates on 5 or 12 volts. And even though there might be some exceptions, they usually expect the voltage levels on data line to be the same as on power line. So if you use 5 volt strip and something like Arduino Uno, which logic level is also 5 volts, then you're good to connect those things directly. The problem is that 5 volts logic level is not very popular. In fact, boards from ESP family, Raspberry Pi or even some more powerful Arduino products that offers way more computing power, memory and other stuff while being a lot cheaper than Uno, operate on 3.3 volts logic level. So if you try to connect such board directly to your strip, there is a chance that they will work just fine, but it may also happen that you will see something like this. The strip might be able to read some data correctly or display something absolutely random. So it's generally a good idea to use a logic level converter appropriate for your LED model. These two rings, for example, utilizes WS2812B LEDs and have no problem to cooperate with 3.3 volts controller, even without logic level converter. But this strip, built of WS2813, absolutely refuses to cooperate with 3.3 volts, even with level shifter meant for WS2812B model. But surprisingly, it works fine when chained with the ring, as well as when used with 5 volts board. I also managed to make it working using such homemade voltage converter. So it seems that WS2812B model is more DIY friendly, but to be honest, I can't say that for sure based on just 3 random devices. From datasheet perspective, their parameters are pretty similar, so maybe if I buy different devices or receive devices from another series, the results would be opposite. It's generally a longer story, so maybe one day I'll make a separate video about it. But if you have your own thoughts on that, feel free to share them in a comment. Okay, addressable LEDs are pretty spectacular, but also the most expensive ones, so probably more often you will opt for monochrome or RGB options. And as they don't have this built-in power control circuit, you need to provide one yourself. From code perspective, it's pretty easy. You just need to use analog write function, setting desired value on relevant pin, and microcontroller will use pulse width modulation to reduce the brightness on given channel. The problem is somewhere else. Microcontroller pins are definitely not meant to work as power electronics. They can accept around 10 mA at most, while such LED strip may require several amps or even more. Also, its working voltage may be higher than what your board can accept. So what to do now? As usual, there are several ways to handle it, but in my opinion, the best one will be to use appropriate transistor. In case you already feel overwhelmed by just mentioning this mysterious semiconductor, don't worry. In this video, I shown that in simple applications like this one, there are just a few simple rules that you need to know to build your own devices utilizing transistor. Here is an example. If you absolutely refuse to do any soldering, you can buy this model for a bit over $1, connect it exactly as shown here, and there you go. For around $5 you have a controller that you can program yourself to do exactly what you need. But if doing some sort of soldering yourself is not an issue, you can prepare a piece of PCB, for example like this, and use this model for just few cents. This way you can make a power module for any number of channels you want to use, while keeping it small and affordable. Really nice feature, especially when dealing with RGB strips that require 3 lines per strip. Of course, those are not the only transistors on the market that are fine for the job, but if you choose the wrong model, it may not work at all or even burn. So if it's supposed to be your first experience with transistor, consider watching mentioned video first, so that you know what you're doing. Link in description. But what if you want to use just a single LED? Or make a custom composition of those yourself? As mentioned before, you need to be aware of two things. First of all, LEDs, like all diodes, have some specific voltage on which they start to conduct current. The problem is, this characteristics quickly becomes nearly vertical, so you can't just apply some fixed voltage to it, because it is certain that you will miss desired working point. Instead, you need to limit the current to what is specified as acceptable in datasheet of your LED model. Fortunately, in most cases it's really simple. You just need to add a proper resistor in series and that's it. This is exactly the reason why you can find those resistors on non-addressable LED strips. Finding proper resistance is quite easy. You just need to check your LED forward voltage and maximum allowed forward current and divide the difference between a voltage you want to use and LED forward voltage by the maximum current that LED can take continuously. This way you get the minimum value of serial resistor required to keep LED safe. Of course, you can use any value above it, but going below can break your LED sooner or later. You can also use this resistor to adjust LED brightness. For example, it may happen with RGB LEDs that one color is stronger than the others, so you may want to trim it on hardware side. But if you're using microcontroller, you can also do it on software side, whatever is more convenient. There are more efficient methods of keeping the current on some given level, but they are also more sophisticated, so it's well beyond the scope of this video. I'm pretty sure I'll mention them sooner or later in other videos I'm planning, so hit subscribe button if you're curious. Last thing I like to mention is related with power LEDs. Unlike smaller LEDs, they are usually unable to dissipate all the heat they produce on their own. Instead, they have sort of thermal pad called slug that is supposed to conduct the heat to a heatsink, which you need to provide yourself. Sure, there is a lot of other things that can be told in context of LED illumination, but like for an overview, I guess that's enough. Hope you found something useful in this material. Thanks for watching and see you on other videos.